So hello everyone. So in this video we'll understand about arrays. Okay, very important topic. Okay, throughout my data structure we'll keep on using these arrays. Okay, every now and then. So let's understand what is this arrays. Before understanding arrays, let me show you something. If I give you three values, okay, we'll store here some values like we'll take C in A, C in B, and so on. Okay, we'll keep on taking till C, and I'll tell you find the greatest. You'll be like so happy and you'll like just find the answer and you know how to do that. Simple. If I give you 1000 elements, I give you three elements out here. If I give you 1000 elements, I'm going to do the same thing. You'll create A, B, C, D, E, F, G, H, so many storages, still like 1000. I don't know what names you'll be using. Maybe you'll use A1, A2, A3, and so on. Okay, maybe. Do you think we should do that? It's gonna be really frustrating. Okay, why? Because you need to maintain all those values. You need to keep on comparing those values. You need to know the names of those values. Understanding? It's gonna be really hectic. Okay, so that's not possible. Practically, it's not possible. Obviously, you won't be wasting your time writing 1000 unnecessary variables, right? So what's the catch? What's the thing that we can do? Well, to the rescue, there's something called array. What arrays does is, it's like, okay, fine, you want to create, you want to store 1000 elements. Just come here, name of the element, like we have like A1, A2, A2. This square brackets tells us it's an array, okay? And inside this, we are gonna store 1000. Okay, that means it's gonna be int arr. See, this arr can be any name. If you want to just give a and 1000. This said, I have actually created element of 1000, which can store 1000 elements. How? It would create a continuous line, okay, where you can store all of the values. Make sense? If you want to store here 1, 2, 3, we'll see how we'll store. Okay, don't worry, but we can do it. But what's the advantage of this? Did you need to actually create all different values of different variable names? I cannot see any variable names. Actually, this you can access all the elements using this A. How? Example, if you want to go and access 4, okay, how will you access? Actually, this is the indexes, okay, through which we access them, and I'll show you why they start from 0 also after some time. Okay, these are the indexes. If you want to access them, assume that you have actually stored the value like this. We'll see how we'll store it. Right now, understand that we have stored the values. Okay, and how to access this 4? How will I access it? Just write A of 3. A of 3 means, see, while creating, you create it using this. That means there are 1000 elements inside my array. Okay, but if you want to access this element, you need to access it using your indexes. So if you want to access this 4, you need to go A of 3. A of 3 means it is equal to 4. Making sense? See, it's fine. Obviously, we'll code and understand. The best part is let's just code. Okay, let's just code and then understand. It's gonna be fun. Just clear this part. Okay. So see, what I'm saying is, let's just take a small array. Okay. So see, if you in order to create an array, you need to write square bracket. Okay. And you can suppose the size is gonna be 10. You want to create 10 elements. Okay. Great. Now, how do we actually put the values inside of it? You can actually put them like this. C in A of 0. So what will have happen is, see, right now I have written 10. So a space of 10 elements where I can store 10 elements have been created by the program. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 means 10 elements, right? If you count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements, okay? 10 elements can be stored here. But these are the indexes through which I'm gonna access them. Okay. And we'll know after some times why do we use the indexes from 0. Okay. Right now I'm writing here A of 0. So whatever value I put here, it will go and store here. Example is, say I'm gonna write here 2. If I write here C in A9, that means if I'm gonna put here 10, then A9 will go and the value will be 10 here. If I write here C in A7 and I want to put here, let's say 3, then I can just put here 3. Okay, if I whatever I put here, that will go on E7. E7 means index 7. Where is index 7? Here. Go and put here 3. Does this make sense to us? Why do we need? After we have entered all the values, okay, and then obviously we aren't gonna do this. We'll see a shortcut to it. Obviously, if you have 10 elements, you're not gonna write C in A0, C in A1, C in A2. Sorry for the handwriting. C in A4. Are you gonna do this? No, obviously not, right? It's just useless. Obviously, just useless. We'll see the trick how we can actually reduce it. Okay, because just say if you have 1000 elements, are you gonna write it till 1000 times? Obviously no, right? Make sense? Do you know understanding what we're doing? So let's actually store the values and see. Okay. Right now I'll just use the scene. Okay, but later I'll show you how we can actually store the values in a shortcut way. Okay. So right now I've stored here, and right now again if I store here, let's say I want to store at a of 3. Okay, and come and print the value of a of 0. Okay, that means print whatever is kept at a of 0, and also print whatever is kept at a of 3. Okay, likewise like this, like we have an integer b which is equal to 10. Okay, so if I see out b, so what do I'll get? I'll get 10, right? Obviously, making sense, right? So that's the thing what I'm saying. Let's, and after printing the value of b, let's actually try to write this. Enter the values of d and okay, let's see and how it's gonna work. Yeah, that's it. First 10 will be printed because it's at line number 5, right? So let it first get printed. Okay, 10 got printed, and it's asking me enter the value of L. So first I need to enter a of 0. So what is a of 0? Let's enter 4. And again it's asking me to keep it a of 3. So let's keep 6. So what should I get the answer? A of 0 means 3, 4, and a of 3 means 6. 4, 6. Actually there is space. Okay, if you want. Actually I haven't given any space, so it's creating some trouble. Now it's creating trouble. Okay? Now we will just see 3, let's say 4 and 6. Okay, making sense? Making sense? So I'm not actually, I don't want to store it like this. Who wants to store all the values like this? Yeah, come on, no one, right? So one thing that we can do is we can do like this. See, right now my array values is going from 1 till 10. So I'm like, okay, let's get it. Take a loop. Int I equal to 0, I less than equal to I less than 10, because the indexes will go till 9, right? We can see here, right? I'll tell you what I mean. Okay, I plus plus. Can I write like this? Think about it. Can I write like this? See, indexes basically goes from 0 to 1, 3, 4, 5, 6. So first of all I equal to 0. So first of all it will be seen at I0, right? A0. So here whatever I want to put out it out here. Next I will become I equal to I plus plus, right? So again now I will become 1. So whatever I want to keep, okay, I can put it out here, right? Next again I will become 2. So whatever I want to put, I can just put it out here, right? Next if I put it 3, because I plus plus, right? Again at 3 I can put whatever I want to put. At 4 I can put whatever I want to put. It's gonna go basically till 9, because as soon as it becomes 10 it will never go inside. Why till 9? Because the indexes are till 9. If n is the value, then indexes are actually till n minus 1. Okay, making sense? So we're just doing the basics. Okay, what we want to do is let's actually put all the values inside of this array and print all of these values. Okay, let's see how we'll do it. See, through this code we will get all the values inside my array. So how actually I'm going to print it? Let's see how actually we're going to print it. Well, we can do this. For int I equal to 0, I less than 10, I plus plus. Okay, and I want to see out whatever is being kept at a of I with a space. Okay, let's give a space. Does this make sense to us? This is gonna take all the elements. This is gonna print all the elements with a space. Okay, so let's just try it. Okay, so let me give some elements like Ajax. Okay, Saxing. So I'm giving 1, 2, 3, 4, 5, 6, 8, 9, 7. Okay, and I'm really sorry. Again, one more small error. It's basically your sorry. I think I didn't give all the values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, can you see what's happening out here? We're getting everything printed like this, right? See, I have given the values and everything is getting stored in the contiguous form, continuous. Okay, that means I'll show you. See, here I created an array whose name is A, and it's gonna contain from 0 to 9. Okay, values. Okay, this is actually continuous. Okay, wherever it's stored in the memory, it is actually stored as a continuous memory location. Okay, that means if the address of this is 100, then this is gonna be 104. Why 104? Because this is actually an integer, right? If you see properly, what is the size of an integer? 4 bytes. So if in case this is 100, then the next integer is going to be stored here. That means this is going to take 4 bytes. So 4, if it takes 4 bytes, so 100 plus 4, 104. So obviously next will be at 104 only, right? Make sense? Okay, I'll just show it to you why I'm saying this. Assume that there are 10 elements and each of them they take size 4 bytes. So 10 into 4, obviously. So its size gonna be 40. Everyone agrees with me? Okay, we'll see it. We'll just see the size after this. Okay, but before this, let's just see this. We are taking the input here, and after the input has been taken, I'm actually printing them here. How I'm printing them? I'm going see because I know that the indexes start from 0, so I'm starting a loop from 0. Okay, I'm starting a loop from 0 in both input and output, and I'm going till n minus 1 because right now I know the size of my array is 10. Okay, we'll see. We'll discuss how we can actually go through these values. Okay, but right now I know that my size of array is 10, so I'm going till 10, and I'm actually going till 9 because I know the indexes size till 9 only. So I'm writing here, I'm going till 9 and I'm actually taking the input. A of I means first go and put at A of 0, then I will be plus plus, go and put at A of 1, and then similarly A of 2 and so on. Similarly, the output, first give me the output of A of 0, then A of 2, A of 3, and then till A of 9. Making sense? So that's what it gave me here. Okay, it gave me the output, right? Okay, so now let's see the size. See, this array is basically of size 10. Okay, from 0 index to this is the index value. Okay, from 0 to 9, this is the index value, but the size is actually 10. So 10 means 40 bytes. Why? Because each is an integer, and an integer contains 4 bytes. Size of each integer is 4. So the total size of this is gonna be 10 into 4. Why 10? Because 10 is the size that I have given out here. Okay, out here, which is an integer. So one integer means 4 bytes. So 4 into 10 means 40. Okay. So let's see how we're gonna get the size. Okay. Okay, come here. See, I'll just comment this out. Okay, because we saw how to take the input, right? So let me just comment this out. I'll come here and I'm like, okay, see out. We know this, right? We know this, right? Size of operator. Let's first take the size of b. B is actually an integer, right? What's the size of b? 4, right? It depends on compiler to compiler, but usually it's 4. Okay, so see, it's 4. Okay, and let me comment this out because we don't have to actually see out these things also. Okay, so size of b is 4. That means the array is actually containing 10 integers. That means each integer size is 4. So it should give me 10 into 4, 40. So see out size of a. What should you expect? If I give here NDL, what should you expect? 4 for B and 40 for A. Okay, let's see what we're gonna get. We got 4 and 80. Just give me a second, I'll show it to you. Making sense? Why you're getting 40? Making sense? Okay, so in this video we have seen till here. In the next video, see, we have seen how to actually store the values in an array, right? In the next video we will come across about how to find the greatest among all the elements. Okay, okay, right now I hope you understood these sizes, the differences at sizes, right? And also let me actually tell you one more thing. What actually happens is, why do the indexes start from 0? They start from 0 index because the, see, if I actually see, okay, this part is also clear, right? So I'll show you something. If I write it cout this b, this AND operator basically tells you the address. We'll see these things in more detail when we'll study our pointers, okay? But right now understand this will give you the address. Address means wherever b is made, okay? Obviously b will take some space in the memory, right? So I'm like going to its location and saying at which address is b made. So if you see properly, it will give us an hexa address. How do we know this is an address? Because 0x. 0x means address, okay? Making sense? Okay, great. Now what happens with the address is, if I come and print it out here like this, cout address of a, or if I print address of a, or even if I print a, it's gonna give me the same answer. Okay, I'll show it to you. And t. Okay, because through a I can't access anything. If I want to access, I need to go to a of 0, right? A of 0 is only the way I can access the values. So if I write here a, then it will give me the address at which a is made. Okay, let's see. The addresses are same, right? That means address of a also is giving me same thing, even a is giving me same thing. Making sense? Okay, now come. Suppose I have actually created like a of 0, okay, a of 0 equal to, let's say, 10. Okay, and if I'm printing the value of a of 0, I can just do a of 0 like this, right? So what will a of 0 give me? A of 0 will give me whatever is stored at a of 0, that is 10, right? So let me show you this. We'll get 10, right? That's great. But what if I actually do this? Cout address of a. Okay, and let me comment this, and let me show you the address of a and show you the address of a. This three. What do you expect should be the answer? Everything will be same. Let me give you space so that you can actually understand that they are same. Here, see, these things we'll learn in detail when we'll do the pointers, but right now I want to make sure why we use the indexes from 0, okay, and not 1. Okay, I'll show it to you. Can you see all the addresses are 0 starting from this also same, this also same, this also same. That means they are stored at they are pointing to the same location. Okay, that means what actually happens is, when your array is created, okay, when your array is created, then this address of this example, let's say 100. Okay, 100 is the address of a of 0, obviously. Okay, and also this is the address of a. That means from a, what is the distance of a0? Obviously if it's 100, if both of them is 100 and 100, what is the equal to 0, right? That's why the indexes start from 0, because I'm saying that what is the distance of a0 from a? It is 0, right? If I ask you what is the distance of a1 from a, it's gonna be 1. Why 1? 1 basically denotes that one integer. One integer means 4 bytes. Okay, so if I actually come and actually even see out the value of a of 1, okay, address of a of 1, if you see properly, it will be a difference of 4 bytes. Okay, I'll show it to you. If I come here and say this, cout address of a of 1, okay, again saying, let me just give this here and there. See here, it was at 0, right? 0 plus 4 is 4. Okay, in hexa it's adding 4 value. That means it's actually pointing to the next integer. Next integer size is 4, so this took this size from 0 to 3. Okay, and next integer is stored at 4. Making sense? See this part, this 4 and this part, 0 and 4. Making sense what's actually happening inside? Okay, that's the reason we use indexes from 0. Indexes from 0 we use, why we use, because even your a points to the same memory location, and even a of 0 points to the same memory location. That means a of 0 is at distance 0 from a. Okay, so this was just the basics. Okay, this was just the basics. We in this video, what did we understand? We understood that if you are trying to print a, then it will actually give you address. It will give you address. Okay, unlike integer a, if you have some integer b, and if you're trying to print b, then it will give you the value. But if you're printing the a of an array, it will give you the address. And you saw a is also giving the same address, and even the address of a of 0 is giving the same address. Okay, remember I have used address. If I used only a of 0, then it will give me value. Okay, now see, we have learned this, and we even saw how to take the input, how to give the output. Okay, so this is just the basics. In the next video we'll see some more things. Okay, so see you guys there. Thank you.